You recall that I described our course project as being a menu-driven program, or at least it will be. Now, menu-driven implies that the user will be presented with a series of choices, and depending on which choice they choose, our program will do different things. For example, if they choose to create a record, then we will execute the creating record code. If they choose to delete a record, then we'll execute that code instead. So in order for us to be able to do this, we need to explore the language constructs that the Bourne shell offers to allow us to execute code conditionally. In other words, if a certain condition has been met, then execute the following piece of code, and if some other condition has been met, then execute some other piece of code, and so on. So, the aim of this chapter is to get us to the point where we can modify our course project and add conditional code to it. Specifically, we want to add a menu to it. So let's begin. We'll begin with the most important concept that we have to learn in this chapter, and that is the notion of true and false. Now, we probably already understand what true and false is from a social perspective, and probably even from a logical perspective. But we need to understand true and false as it pertains to shell programming. So let's look at what I mean by that. The first thing that you need to know is that when every Unix command completes, it does something that you probably are not aware of. It actually invisibly returns a value to the program that started it. Now, the program that started it is usually going to be the shell, either your login shell or the shell script that you're running. So a value gets passed back from the Unix command after that Unix command has completed, and it tells the program that started it, the status, the completion status of that command. Let's look into that in a little more detail. The value that gets passed back is actually a number, and we call it the exit status of the given command. Now, this has been happening all the time ever since we've started using Unix, and most of us are blissfully unaware of the existence of this exit status, but it's there. We usually ignore it, as does the shell. But we're not going to ignore it anymore. It's actually pivotal to this entire chapter. So let's have a look at it. An exit status of 0 usually means that the program completed with no error conditions arising. Now, what might be an error condition? Well, if you did an ls, for example, of a file that didn't exist, ls might return an exit status to the shell that called it which would be non-zero. A non-zero would mean that some error occurred, and the error that occurred in this particular case is the file is not there. So again, if you ran ls a second time, and this time you asked it to list a file that did exist, then you would probably get an exit status of 0. Now, this is all convention. It doesn't have to be an error condition, of course. For example, the program diff is used to compare two files, will actually return an exit status of 0 if the files are identical, and return an exit status of 1 if they're different. Now, 1 typically means that some error has occurred, but not in the case of diff. It simply means that the files are different. That is not necessarily an error. So, is there any way of actually examining this exit status to find out what it actually is? The answer is yes. The exit status of the last command that ran is always stored in a built-in variable called question mark. It seems like an odd name for a variable, even an illegal name, but nevertheless that's where it's stored. So you can have a look at it at any time using the echo command, just going echo $question mark. You can examine the contents of this variable at any time, and every time you run any command at all, including just examining the status of that variable, then that's the contents of that variable get overwritten once that program completes. So that $question mark is constantly changing. Let's have a look at one. Let's have a look at how that actually works. So the first thing we need to do, of course, is to actually run a command. Let's run the ls command. Okay, so there's an ls running. Now let's find out whether ls returned an exit status to us. Well, it will have. Let's find out what it is. And it is 0. So let's try that a second time. Let's say ls, and this time we'll specify some file that definitely does not exist. And we get an error message on the screen but we also get, if we know where to look, an exit status of 1. Now, just to prove that last comment that I said, I'll run echo $? A second time, and notice this time it's 0. Why has it changed? Well, it changed because that first occurrence of running echo $? Is actually a command, and that command produced an exit status of 0. So when you run echo $? A second time, you get to see the it's confusing, isn't it? The exit status of the echo that we just ran just a moment before. Now, one thing I want you to keep in mind is that these exit statuses are not absolutely reliable. You'll generally find that virtually every Unix program you ever run adheres to this standard. In other words, if the program completes with no errors, then you'll get an exit status of 0, and if the program produces some sort of error, then it will let you know via the exit status. But you can't rely on this. Some programs have not been designed that way. And some programs, such as diff, actually use the exit status to tell you various pieces of information, like there were differences or there were no differences. Anyway, let's look into exit statuses in a little more detail. Here's the important thing for this particular chapter. It is actually useful for us, the shell programmers, to think of this exit status as a true or false value. And you think of it like this. 0, which really means no error, you can actually think of as meaning true. And any other value, any non-zero value, you can think of that as meaning false. What it really means is there was probably some kind of error, but we'll think of it as meaning false. Now you'll see why in a moment, but before I mention that, I'll just add that in some programming languages it is exactly the opposite. In other words, in C, for example, C treats the 0 value as false and anything else being true. And in C that really is true and false, whereas in the shell it's not really true and false, it's really error and no error, but it's occasionally useful for us to think of those errors and no errors as being true or false. I'll show you examples of that shortly. Interestingly, there are actually Unix programs called true and false that can demonstrate the use of these conventions, and I'll just show them to you briefly. There is a program called true, and I run it, and it does absolutely nothing except it produces an exit status of 0. Similarly, there is a program called false, which also does nothing except to produce an exit status of 1. They're not particularly useful programs, but keep them in mind because occasionally a use for them does come up. It's often useful to have a program that does absolutely nothing for your shell script, and it's also useful if you want to create an infinite loop or a forever loop, and we'll look at loops in a later chapter. But for now, I just want you to cement into your head this notion of an exit status. Go and have a play with some of your favorite programs, see if you can get them to produce an error, and if they do, have a look at their exit status, and if they don't, have a look at their exit status anyway.